Hello to all viewers of the YouTube channel Electrician 1. In today's video clip we will be testing voltage with universal measuring instrument. When using a universal measuring instrument, the most important thing we need to do is to connect the measuring cables correctly. No matter what we want to measure, we need to connect the black measuring cable to the port marked COM. The red measuring cable, in case we want to measure voltage, will be connected to the port above where the letter V is. When we have done that, we need to turn on our universal measuring instrument, and the next thing we need to do is decide whether to measure direct voltage denoted by a horizontal line after the letter V, or we will measure alternating voltage denoted by a sinusoid, a wave as students say, after the letter V. In the first example, we will measure the voltage on the batteries. We all know that this small battery, marked AA, has a voltage at its ends of 1.5 volts. But the basic rule of using a universal instrument is to set the selection knob to the maximum position if we do not know the voltage of the source whose voltage we are measuring. We'll try to see what will happen. We connect the minus terminal to the black measuring cable, and the plus terminal to the red cable. We can see that the display shows number 1, which should mean that the voltage of this battery is 1 volt. So we are free to reduce the measuring range to a lower value. We'll change it to 200 volts to see what happens next. We can see that now the display shows 1.5 volts. So we have a slightly more precise measurement. We can still reduce it. Let's go to 20 volts. We are performing the measurements. The measured value in this case is 1.56 volts. We conclude that the closer we are to the exact value we are measuring, the higher the accuracy of the instrument is. So we can put it in the 2 volts range. We are measuring again. In this case, the display shows 1.565 volts. We can see that we now have an accuracy of 3 decimal places. And that is exactly the voltage that reigns on this battery of ours. Let's see what will happen if we accidentally or out of ignorance change the polarity. So we put the red measuring cable, which is A+, on the negative terminal of the battery and the black on the positive one. We can see that the measured value will be identical, as in the previous case, with 1 minus sign, which indicates that we have incorrectly polarized our instrument. If we want to measure alternating voltage now, we will put the selection knob in the interval marked by a sinusoid, which is 2 to 700 volts alternating voltage. We will take an extension cable for single phase current, and the voltage between phase and zero we know is 230 volts. And we'll check that out. We will put the selection knob at a higher value than the one we are measuring. In this case it is at 700 volts. You need to know when measuring alternating voltage, that it doesn't matter how we turn the measuring cables. We don't have to know where the phase is and where it is zero. We will start measuring. And here our display shows that the voltage between phase and zero is 239 volts. For a long time now, the nominal voltage between phase and zero in our electric power system has been 230 volts. Here, due to the proximity of the substation, that voltage is slightly higher. If we change the polarity, change the places with cables, nothing will happen. We don't see the minus in front of the value, and we get the same measured magnitude of 239 volts. Thanks for watching this video. Please share it with your friends and invite them to subscribe to the YouTube channel Electrician 1. Kind regards until the next video.